Okay, let's talk about humidity. Now, humidity can be a pretty tricky subject for the most part. Like in college, it's a kind of a wrestling match students will have with it. But on the other hand, in third grade, you talked about it. It's basically how much moisture is in the air. Right? Not a big deal. But how do you quantify that? How do we talk about how much moisture is in the air? You can feel it, right? If you go to Florida compared to Arizona, you'll feel it. But how do you measure it and quantify it? There's kind of two ways to do it. One of them's not really used. We could measure the absolute moisture that's in the air. How much? In grams or mass or something. We'd call that the humidity, absolute humidity maybe. But that doesn't, it's kind of hard to do. How would you measure that? The other way to do it is what's called relative humidity. And relative means it's like a ratio. It's actually a percentage, right? We multiply it by 100. So we take the amount of water that's in the air and divide it by the maximum amount that could possibly be in the air and multiply it by 100. Right? So the idea is that if it's 100% humidity, you're dying. You're sweating like a pig in Florida. Right? If it's 0% humidity, it feels really dry. I don't know if it's ever really zero anywhere. I don't know. But it's a relative term. It's times 100, and it's a percentage. Okay. The other term you got to get a grip on is the term, we call it evaporation, kind of a trivial term, right? But evaporation is the molecules of water leaving a liquid and going into vapor. And then the other one is condensation. That's a molecule of vapor going back into the liquid. So it's up is evaporation, down is condensation, if you wish. Okay, so you got to get a grip on those. So let's look at an example here. Say you had a beaker, and it's red because it has warm water in it. And then you had another one, and it's blue. It's supposed to be the same size, same amount of water, but it doesn't really matter. Now what's going to happen here, some of these molecules are going to be leaving, and they're going to leave the liquid and go into the air. Now over here, they're going to be doing that too, but not as many. I don't know. Let's say this is 10 and this is 70 or 60. I don't know. It doesn't matter. So this is warm, this is cold. So it's going to be a lot less. The evaporation rate is a lot less for this cooler water over here. Right? And so you can kind of envision that if these were water molecules, there's going to be a lot more of them above this point than this point. So you could say the absolute humidity here is greater than here. Right? But let's put a lid on these guys. And the point is, as long as these molecules are leaving the liquid, then that means we're not anywhere near the maximum amount. Right? But what's going to happen, and even without the lid on it, is we're actually going to have molecules returning to the liquid phase, right, like that. Now at this point, if the numbers of arrows matter here we've got 4 up and 2 down, here there's 2 up and 1 down. So here, the rate of evaporation rate is greater than the condensation rate in both of these. Right? So there's still a net movement of molecules going up into the liquid phase, right? The vapor phase. So it doesn't have the maximum. So in both these pictures, these are less than the maximum amount of water vapor. So the relative humidity in these is still less than 100%. But if we let it sit for a while, what would happen? We'd reach a point, I don't know where I'm going to fit it in, where the rate that molecules are leaving the liquid and going to the vapor is equal to the rate that the molecules are leaving the vapor and going to the liquid. Right? So what that means is we've reached the point, that's the maximum amount of water that can be in the air at this point in time. So right now, at this picture right here, this is 100% humidity. The relative humidity is 100%. Because we've got the maximum we could possibly have. The thing we got to realize over here, again, this is also 100% relative humidity. I should put the RH here. both of these, the relative humidity is 100% because there's the maximum amount of water vapor in the air, and it's not changing. Right? The rate that it's coming in and going out is the same. So these are both at 100% humidity, relative humidity. That's what we do to talk about the 100%. What about less than that, though? In this case, to begin with, I'll just do 3. It's a little hard to fit that in. Right now, the rate that it's leaving the liquid is greater than the rate it's coming in. So now this relative humidity here is less than 100%. Right? Because there's more leaving. If there's more leaving, then that means there's more possibly in the vapor. I'm trying to word this carefully. I'm going to talk about wording here in a little bit, but it's tricky. Down here, let's do the cool one for a bit. So again, right here, the relative humidity is less than 100% because you've got more leaving the liquid. So there must be more capacity, if you wish, for vapor, water vapor in the air. But what happens, say this was at, say, 10 degrees. Right. What happens if you started to cool this down? Right. So as you cool it down, say to 4 degrees, what's going to happen is more and more are going to leave the vapor and go into the liquid. Okay, you see the problem we've got right here? This would technically be a relative humidity greater than 100% because we've got too much water vapor in the air. So we're basically greater than 100%. Now, this is not an equilibrium state. It's not. If it wouldn't stay like this in time, but that's how it could be at this particular time. That the liquid is producing less than the vapors coming back. Okay, so why do we care about that? Well, here's the deal where it gets useful. Say at 60 degrees, and I don't want to use a different color, but we've got this set up here. Well, I really should have at least one. Okay. And then what happens is we start to cool it down. Oh, shoot, that's supposed to be a down arrow. Sorry. At 60 degrees, we've got this situation. Now let's start to cool it down. And cool it down, cool it down, cool it down, cool it down. We'll get to a point where we have this. Right? And that would be 100% humidity. Okay. Now, if we went a little bit below that, we're going to start doing this. Right? That point is called the dew point. That's the temperature at which the air is fully saturated, and it won't take anymore. And if what's going to start to happen if you keep lowering this temperature is the moisture is going to come out of the air. Okay, that's the dew point.